Okay, for this one, I'll be talking about how ear works. Like how we talk about it in class, there is loud, loud, and then there's a quiet sound. Loud is when it becomes very painful, and a quiet is when it's you can barely hear it, it's pretty quiet. And then there's also halfway there. And for loudness, it will be 1 watt over meter square. And for the quiet, will be 10 to the 12 watts meters over meter square, and where the half part will kind of be like 10 to the 12 over 2, which is like a half. But our brain don't work like that, so then they trying to convert it into a logarithmic way. So we use very little resources on the higher or loud noises, and then we have more resource on the quiet sound. So then the logarithmic scale is perfect for this kind of thing. So we talk about crickets in class, so then we use cricket as an example. So if we hear like about 1000 cricket, how much do we need more to hear it? And in class we decided that it's about 10%, so then we'll hear it, because if we have 1000 cricket and we only add one more, there would not be much difference. But if we have at least 10% of it, you can see the difference. But if we have like about one cricket and you add one more cricket, that will make a difference because the number is smaller. So if there are more then it needs to be a larger change, and if they're lesser, then there needs to be a lesser change. And how we talk about this is how intensity is. So then if they give us an intensity of 10 to the negative 7 watts meter per square, to change it back into the crickets, you need to take 10 to the minus 7 plus 12, which will give you the Bell scale, and that will be 10 to the 5th. And then you take the exponent of it. We get tired of writing the 10 to whatever power, so we only take the exponent. So then we write just 5, and that would be the Bell scale. And then you take that 5 multiplied by 10, which will give you the decibel scale. And you can do that with any number and it will be the same. And you can even do it backward, like how this example show. So if they give you a 40 dB, you will convert it backwards. So then 40, you divide it by 10 will give you 4, and then just put that to the exponent, and to get to the other, you take 10 to the 4 minus 12, and you will get 10 to the negative watt meter per square. And the same thing as this one, give you 30 dB, and then you divide it by 10 to get 3, take the 3 to the exponent, and take 10 to the 3 minus 12, and you will get 10 to the negative 9 watts meter square. And here's another example. This is where the explosion happened, and when the explosion happened, it was spread around 1 meter, and this is where the larger part happened, and this part is the part where it's smaller, and then there will be a larger circle spread, which would be 2 meter, and that is only not one half of intensity. And a half of intensity, it's over the square. So then you would take the 1/4, so that 1/2 to the square, that would become the 1/4 intensity. And if you have another one which they will spread out, and the area of a sphere is 4 pi r to the square, which give you this part. And so to get the third part, you get 1, and then over, since it's the third sphere, 1 over 3 to the square, which will be 1/9, and which is closest to 1/10, which means you lost 1/10 of intensity, and that means a loss of the 10 decibel.